Now, this is our final lecture, and the topic I'm going to look at today is titled Data Fetching and Caching. So we know that an important part of any browser-based app is its communication with a web API, which is where the data fetching relates to. So it's typically either fetching data or sending data to a backend. Either way, it's communicating with a remote server. And because of that, that's an asynchronous operation. So it takes time, if you like. And so we try and minimize the amount of communication that we need to do with the backend and make it as efficient as possible, mainly to improve the user's experience. You don't want to have the user waiting for the screen to refresh or for data to update whatever particular view the user is currently looking at. Now, one technique that we can use to improve that aspect of it, that kind of performance aspect of a web app, is to use something called caching, a technique called caching. Caching is not unique to the communication between a browser and a web API. You can also use caching in other areas of a distributed application. It's also typically used for the communication between your web API and your database. We're not looking at it in that context, but caching as a technique is a good it's a good feature to be aware of when you're developing any kind of distributed applications. And so I'm going to cover it, in our particular context, but hopefully the knowledge that you'll gain from your understanding of caching, you could equally apply to other areas within a distributed system. This area is also kind of related to what's referred to as state management. State management is a slightly different, but it is related to the area of data fetching. And I will mention state management a couple of times during this lecture as well. So let's go into the slides. So to step back for a moment from the detail of caching, I want to just talk about state or data in relation to single page apps. And it turns out there are two aspects to any single page app's data and the data that it needs to manage. There is client state data and server state data. So we're told on this slide that client state data is often referred to as app state as well. It's something that is private to each instance of a client. And examples of it, might make it a little bit clearer. So if we talk about the movies app that we're developing in the lab, and we have the filtering card where you can select the genre and enter some text into the search box. Anything that's entered on that little form, that's obviously private to each running instance of our single page app client, because one user might have selected one thing on the genre list, another user would have selected something else. We have to store which one they've selected somewhere, but we characterize that type of data as client state data. Other examples would be, well, maybe if the single page app allowed the user to somehow theme their UI. Simple example might be dark mode, light mode. There might be a switch that the user can click to change the UI from dark mode to light mode. It's not a difficult thing to do in relation to React, as it turns out. But that would be another example of client state data. The current logged in user, maybe the user's ID or their token, that has to be stored somewhere on the browser, but it's characterized as client state data as well. So what's common about all of these examples? Number one, I'm saying that the client owns it. It's private to the client, and it's not shared with any other instance of the client that might be running. It's not persisted anywhere, not across sessions anyway. You might store it, you could store it in session management and session storage within the browser, or indeed in the browser's local storage, but you would tend to clean it out once the app had shut down within the browser. You don't persist it across user sessions. That's the kind of point I'm trying to make. This idea that it's always up to date, well, I guess it's obvious that it is always up to date within each client. It's accessed synchronously because it's local to your React app. And we know now that in the case of a React single page app, the useState hook is what we would use to store our client state within the React code base. Down here, then I'm talking about how do we manage client state, because there could be quite a lot of client state, so we need to put some thought into how we manage it. One way is each component could manage a piece of your client state, especially if that data is not shared with other components. Or, as we saw last week, we could put client state that's shared by multiple components. We could put that into a context construct in relation to React anyway. That's all fairly familiar to us. That's all client state. Now, it's not really client state that we're interested in today, though. The other aspect of a single page app's state or data is what we characterize as server state, which is data that we retrieve from our backend, but we do have to store it temporarily within the browser. And in relation to this model view controller pattern that I would have mentioned way back, this would now is where the M comes into play in relation to a single page app or in relation to a React app. So examples, again, that we would be familiar with, the list of movies that we download from TMDB, that would be an example of server state. The details about a particular movie, another example, the list of friends in our Friends app. They're all examples of server state data. And some of its characteristics are obviously different to the characteristics of client state data. Number one, it is persisted remotely. It has to be persisted at the back end because it is shared by multiple instances of our client. It's accessed asynchronously because it's over a network. I'm saying here it can change without the client necessarily knowing it. So if one user, let's supposing we had the ability to make changes to a movie's details. Okay, let's just imagine that. So one user might make a change to a particular movie's details and persist it back in the server side. But unless another instance of our client has explicitly kind of refreshed their page, if they happen to be looking at the same movie, unless they explicitly refresh it or manually refresh it, then they won't be aware that a change has been made to the movie data. So that's obviously an issue. So potentially, I'm saying the client can be looking at out-of-date data. And there are ways to overcome this, but again, that's not what we're necessarily looking at today. And we'd use, in relation to React, we'd use the useState and useEffect hooks to acquire and store server state data. It's debatable whether we should really be using useState. Maybe we should be using some sort of third-party library to take care of storing server state data within the browser. For example, you may have come across references to something called Redux, which is a third-party library. There are lots and lots of third-party libraries that handle state management, server state management for single-page apps. Lots of them out there. We're not using any of them. We're using the useState hook to take care of storing our server state as well as our client state. But you could argue that we should really refactor that out separately, but we'll kind of ignore the fact that we're not doing that. In terms of managing server state data, there's a couple of options I'm saying. Number one, we could store server state within a particular component using the useState hook. That would certainly make sense if a particular part of the server state was only used by one component. So there's no point in making it global. So that would work fine. And it would be what I'm calling a good separation of concerns, you know, because it's only the component that needs to know that server state data. It manages that data, and no other component needs to worry about it. The downside of taking that approach is this one here, though. Essentially, every time that particular component is remounted, then it's going to refetch the same data from the back end over and over again. Now, that's not a problem if the nature of that data is such that it is changing very, very frequently. But if it's not changing frequently, then those subsequent kind of fetches that are made by the component to the server side are unnecessary, and we'd like to avoid that. And obviously, every time that component remounts, then there's a double re-rendering of that component going on. So the user doesn't see the data immediately. It has to wait until the data arrives back from the server side and the component re-renders. So that's kind of poor from a user experience perspective. Alternatively, if the nature of the server state data is such that it's used by multiple components, then we could store it in a context. And that would work okay. And the advantage of storing it in a context, because you might remember from last week, the context provider component is very high in the component hierarchy, and typically it's only mounted once and it's never unmounted again, as long as the React app is running in the browser. So there's no unnecessary refetching of the data going on if we store it in a context. The downside of it, though, is potentially, so you might conclude, well, why don't we store all server state data in a context, and then we don't do unnecessary refetching when it's not necessary. The downside of it is, though, that you are then potentially delaying the initial load time of your app while it's waiting for lots of data to come back from the back end. And also, you've got a poor separation of concerns, because you're just essentially lumping all of your server data into one construct, and that's not great. The third option isn't really an improvement. The third option is what I was referencing there a moment ago. We could use a third-party library like Redux to take care of fetching the data, storing it, and providing it to our React code. But the React code, the kind of re-rendering issue still applies, though, if you are using a third-party library. So it's really, I'm saying, the same as option 2 above. And as always, when you've got options, then the best solution is some sort of mixture of the different options that you have, if that's possible. So I'm saying here that we want the best of one, which is good separation of concerns, without the downside of one, which is refetching. And we want the best of 2, which is no refetching, without the downside, which is poor separation of concerns. So it's a kind of a difficult one to juggle. So anyway, that's server state, and this is the focus of this lecture, really. Client state we've kind of taken care of up to now. How do we essentially avoid this kind of unnecessary refetching of server state data every time a component remounts, because we know the components will remount multiple times if you've got multiple pages that make up your app. So we have a simple little app to demonstrate this. And the app just consists of 2 pages. One page, again, it's using my movies TMDB. One page is displaying a list of movies. And these are hyperlinked, and if we click on one of them, then we go to a page which shows us some details on the movie. I'm just outputting the JSON here now because we're not really interested in UI at this stage. What we're really interested in is the data itself and managing the server state data. To get the app, you go into the section that we're dealing with. You know the routine at this stage. Just grab this archive here, or when you download it and zip it, what you will see is this folder. And you can just import that directly into VS Code. So that's the app. And there are 2 pages, and I'm saying that both pages make a HTTP request to TMDB, which we kind of we have a sense of that. Now, the problem is if we examine, if we examine what's happening at the network level as we navigate around this application, then what we see is something like this. And what I'm trying to get across here, and I'll demonstrate it now in a second to you. Let's supposing we start at the home page, and my React app makes a request to TMDB to get 20 movies from the discovery endpoint. Then let's say we navigate to the first movie on that list. So it displays the movie details page. And that movie details page causes my app to make a request to TMDB to get the details of that movie and displays it. Then if we navigate back to the home page, here we go again. The app is going to re-request the 20 movies from TMDB. And let's supposing we navigate to the same detail page again, it's going to make the same request to TMDB for the details on that movie. So clearly, bar the first 2 requests, some of the rest are unnecessary. And we can just see that happening live. So if I bring in the code into my VS Code. So this is the archive that I've unzipped from the website. And in terms of the code, there's my 2 pages, my home page and my movie details page. And the components, which we're not really interested in, but again, they're kind of familiar. We've got a movies component, which displays the movie on the movies detail page. And we've got this filter movies, because I can do filtering as well, although we're not interested in filtering functionality today. So it's really these 2 components which represent our pages. And if we look at the home page, you know, here we're storing just the text, the contents of the text box, the filtering text box. Here we're storing the set of movies returned by TMDB, and we're making our HTTP call inside a use effect hook. So all of that is fairly familiar. And in the movies detail page, similar kind of stuff. We're storing the movie in a state variable. We have our use effect hook. Yeah, so if we just run it, I guess. So I've already done my install. Just ignore that for now. Open up my developer tools. Make sure you access the network tab, which is, in my case, is this one here. Also, if you select, let's see. Yeah, you see you have different options here. I'm not really interested in the request that my React app makes for JavaScript code, which it does initially. Obviously, it requests the JavaScript code and maybe any CSS code from the development server, but I'm not really interested in seeing those HTTP requests. You might be interested in them in a different scenario, but not today. What we're interested in is this one here, any fetch requests. So make sure you select that, because otherwise, if I select all, for example, and I just do a manual refresh, there's lots of stuff being sent down, mainly JavaScript code that's being sent down to my browser from the development server that comes with the Vite tool. But I'm not interested in any of that stuff, as I said. So I'm just going to select this one here, fetch XXR. And now we can just see the fetch requests made by my app. So again, I'll just do a manual refresh again. Okay, and that's the HTTP request for 20 movies. I select the first movie. Here's the request for that movie's details. That's all fine. If I go back to the home page, it's fetching the 20 movies again, unnecessary. If I select the same first movie on the list, it's making the HTTP request all over again. So can we avoid those unnecessary refetches? And you can see that they're all full requests. They're all status 200. They're not any of the status 300s that you might get where the backend tells the browser the data hasn't changed since you requested last. I don't need to send it to you again. So we don't get that benefit really. So that's the problem. And I'm just explaining the problem there. Now, the solution is, or a solution is, to use caching. And what is caching? Caching is where you store temporarily the API data, your server state data, store it locally in the browser, which makes sense. And the benefit of caching is it reduces the workload both on the browser, but it also reduces the workload on the backend, because the backend is not receiving as many requests. So you can imagine if you had hundreds of thousands of users using your React app, and we didn't employ caching here now in our solution, which we've yet to see, then there are just way too many requests hitting our backend as a result. So that's an extra benefit on the backend. And it speeds up, I'm saying, the re-rendering time when we revisit pages. So because what caching will mean now is that we no longer need to make the unnecessary requests to the backend. We already have the data locally in the browser. And so we're accessing it synchronously from here on in. Here, I'm just describing how caching kind of works. So I've got my React code, my single page app code. I've got my cache functionality. Note now that the cache functionality and your SPA code are all resident in the browser. I probably should have made that clearer from this picture, but they are co-located. So any communication between these two is synchronous. And then I've got my backend or my API. So the way caching works is your React code, first of all, it asks the cache, do you have a particular piece of data? And it specifies the data by using a key. We'll see in a second how we can decide on the keys. So it says, essentially, do you have a particular piece of data? Here's the key of the data that I'm interested in. And if the cache doesn't have it in its data store, then it sends the request for that data to the backend. Backend eventually responds, stores it locally, and then gives the data to your React app, and it renders it. Subsequently, when the React app asks the cache for the same data by specifying the same key, The cache will now realize I have that data. I don't need to go to the back end, and it'll just provide it immediately. Simple as that, really. So what are caches? I'm saying caches are in-memory data stores. Okay, they have high performance because essentially they're local to the client or to whoever is making the request to them. But they are essentially just in-memory data stores. I'm saying that from a structural point of view, they're just key valued stores. So it's a bit like a map structure, if you like, but a little bit more sophisticated than that. The keys have to be unique. The values can be anything you want them to be in general, as long as it's serializable. So the value could be a primitive, an array, an object, an array of objects, etc., etc. Anything that's serializable can be a value associated with one key. We have this notion, this is just kind of caching terminology now, and if you've come across caching before, then you will be familiar with this terminology. We have the notion of a cache hit and a cache miss. This is just terms that we use. So if I go back to the previous screen, what we would say is that a cache miss occurred here. Cache miss means that when the client asked the cache for a particular piece of data, that data was not present in the cache. We refer to that as a cache miss. Whereas when a client asks the cache for a piece of data and it already has it, then we refer to that as an occurrence of a cache hit. I'm saying caches have a very simple interface. Essentially, there's only a tiny set of operations that any client would want to carry out with a cache. There's the kind of cache, this is in very generic terms now, there's the kind of cache get request that a client might make, where it specifies the key of the data that it's looking for, and it returns, the cache returns the serialized value associated with that key if it has it. Of course, if it doesn't, then we know what happens. It makes the request to the ultimate backend, and when eventually that data arrives, it will then return the serialized value. So this request here could be synchronous or asynchronous depending on where the data is. Sometimes the client may actually want the cache to delete an entry from its data store. So you tend to have a delete operation. A purge operation is where the client can actually get the cache to purge all of its data, because caches could actually build up over time, and because they're in memory data stores, we don't want them to grow too big, because then they become slightly unperformant. Next, I'm saying that cache entries have a time to live. When you're configuring your cache, in general, you would specify a time to live for each entry in the cache, not on an item by item basis, but kind of globally. And choosing an appropriate time to live can impact on the overall performance of your cache, because you don't want data, not so much, well, performance and also the potential staleness of the data in the cache. You know, if the data, if the nature of the data of the server side data is such that it is changing frequently, then you would set a low time to live potentially. And what low is now really depends on the nature of the data, but you would set a low time to live so that the cache, the time to live is what the cache uses itself to determine when it should remove entries from its data store. Up here, I'm talking about the client explicitly telling the cache to delete an entry from the data store, but the cache also needs to self-manage the data store. And that self-management is controlled by whatever you choose to be the time to live attribute that you want to associate with all of your cache entries. And the cache takes care then of removing entries from its data store once an entry's TTL expires. It does that for you. So these are just general aspects of caching that I mentioned here. Again, kind of for completeness sake, we're not going to get into the nitty-gritty of choosing TTL times, et cetera, et cetera. So to come back to our React app and our problem, a little app that I demonstrated there a moment ago, there is a third-party library called React Query, although when I looked it up today, just online, it seems to have rebranded itself, but originally it was called React Query. And the rebranding, I think, has occurred really because of the popularity of this third-party library. So what it is, what React Query is, I'm saying is a third-party JavaScript. Okay, originally it was written for React apps, but it can be used with different single-page app frameworks. So Angular, Solid, Svelte, all of them use this can potentially use this third-party library. I guess that's why they rebranded it. It's no longer called React Query. It's now called Tan Stack Query or something like that. It's Tan is a reference to the person that developed it. And what's nice about it is that it provides hooks, right? So that's an indication that it was written originally for use with React apps. So that's the way we actually interface with this React Query library, is through the medium of hooks. And so here's the main hook that you would use, the use query hook. This is essentially the way you would implement a get operation against the cache. And in the use query hook, you specify the key of the data that you're looking for. And you also specify what's called the query function. And the query function is something that you write, because React Query obviously doesn't know anything about the nature of the web API that your React app is using. For example, it doesn't know anything about TMDB. So you've got to provide React Query with a function that encodes how it should communicate with the backend. So we've got to write that function and give it to the React Query library. So when you use the use query hook, specifying a key, and you also give it a reference to the query function, if it already has the data in the cache, then it simply returns it. If it doesn't, it invokes this function, which takes care of communicating with the backend. When the response comes back from the backend, it then takes the response and puts it into the cache, and then returns back the data to you. Now, what it actually returns is something a little bit more elaborate than that, and I'm showing you here that it returns this object structure, really, and a number of parts to it. The data key within this object structure will refer to the data associated with the key. And now, initially, let's supposing there's a cache miss, which means it has to invoke this function first to get the data. So the use query hook, when it responds, and it will respond synchronously, but when it responds the first time, data will essentially be pointing at null. Error, well, no error has occurred so far, so that will also be null. Is loading is a Boolean. That's actually going to be true, because is loading means that it's waiting for the data to arrive back from the backend. Is error will also be false. So the use query hook will respond that way initially. Eventually, when the data does arrive back and it puts it into the data store, now it kind of essentially updates this structure. Data now will be pointing at the actual data in the data store, in the cache. Error hopefully will be pointing at null, assuming no error has occurred. Error is dictated by the HTTP response status. Is loading will be false because it has now loaded it into the cache. Is error will be false. So we use these values here within our React code to try and determine, do we have the data already or not? If we don't have the data, then maybe display something on the page indicating that we're waiting for the data to arrive. If we do have the data, then render it on the page. If there's an error, then, well, it's up to us to decide what we want to do. When an error occurs, we might display something to the screen or go back to some default page using programmatic navigation. It's really up to us. So that's the main interface that we use with this React query library, the use query hook. And as I said, it's essentially, it's a get operation against the cache. The use query hook, I'm saying down here, it does cause a component to re-render. If you take that scenario where a cache miss occurs, then clearly our component needs to re-render once the data has been returned from the web API. But we don't want to freeze up our UI. And so initially, is loading is going to be true, and we display something temporarily on the screen. And very last, I'm saying that essentially the use query hook means that we can now get rid of our own use state and use effect invocations in our code. They essentially replace them. And if we looked inside the detail of use query, we probably find that it uses use state and use query. Well, maybe not use state, but it certainly may use use effect, sorry. It uses use effect internally. So, okay, before I go on to the next, so what that means is if I go back to my code and I've provided a README, and the README explains how you can change the code so that it's now using the cache. So let's just do that. If we look at the home page first, and if we open up the README, and essentially tells you, go into the home page, which is saying here, right? Go into your home page and replace this code that's currently in there and replace it with this code. So let's just do that. So I'm going to comment out this because it's no longer required. And if we just glance at the code, so here I'm using the use query hook. I've just decided arbitrarily the key that I'm going to use is discover. Okay, that's kind of reflecting the name of the the TMDB endpoint that I'm using, but I could have used any string that I want to. And I'm also providing a query function. And this query function, we've already seen the code from that or something very similar to it before. But if we just take a quick glance at it, where do I have it here? There's my query function. So there's no real surprise there. And so that has now been saved. So if I go back to my running app, and I'll go back to the home page, and I'm going to do a manual refresh to make sure we're testing like with like. So it's made a call for the 20 movies from TMDB as we'd expect. Let's select the first movie. It's made the call for that movie's details. Now, if we go back to the home page, it hasn't made a subsequent request to TMDB. So mission accomplished. It has actually got the list of movies this time from my React query cache. Go to the same movie, still making the request of the movie details. But every time I go back to the home page, it's not re-requesting that data. So that means, I got a cache miss when this occurred, but for every subsequent time I revisited the home page, I got a cache hit. And, if we, in terms of the code, so the first time this component rendered, which was at mount time, then, the use query, as I said, was a cache miss. And you can see here, I'm just checking to see, is loading true? So when the cache miss occurred, is loading would actually be true. And so even though we don't see it because it's happening so quickly, my app does temporarily render this up onto the screen. Eventually, and as well, the React query is going to execute my query function. The data comes back, and eventually then data is now going to be pointing at the list of 20 movies. This component is going to re-render because the use query causes the re-rendering to happen, just like a state change would cause a re-rendering to happen. When the re-rendering happens, is loading is now false, so it skips over that. Is error is also false, it skips over that. I grab the movies from, well, what it returns. Data here is what the React query returns, and that's essentially the full HTTP response that came back. And we know we have to index into the results property of that HTTP response to get the actual movies, and then I render the movies. Okay.
Sorry, Dermot.
Mm-hmm.
Question on the cache there. You've got discover as the key for it. Will it change? How does it know that the data isn't stale in the cache, or if you change discover to something else, will it? How does that work?
Well, there's two questions there. The staleness is controlled essentially by me. I set a time to live. Now, of course, what I haven't shown you is if we go into index.jsx, here is where I first of all instantiate the query cache kind of runtime within my browser. And you know, a lot of it is boilerplate stuff, but for example, I do here, I'm kind of let's see here, sorry, here is where I'm setting my TTL, and I think I've set it to something like an hour, right? Because I know the nature of my data is such that it's not going to change over an hour-long period, in fact over a day period. So that's the answer to the question. How does the React query know whether the data is stale or not? Simply because this hasn't expired. And the second part of your question, remind me what the second part of the question was. Sorry.
So it's reliant on the key discover being in cache.
Oh yeah.
To
Well, I've just arbitrarily decided that discover was the key.
I suppose I'm just saying it just looks up to see if the key discover exists in the cache.
Correct.
And then does it? Okay.
Yeah,
right.
Simple as that, really. Just it's a simple string match, string comparison.
Perfect. Thanks.
Now, it's interesting you brought up the key, though, because the example of that key is, I guess we describe it as a non-parameterized or a static key. But quite often, the keys could be a parameterized key. And that arises, in our case, because potentially our cache is going to store details about lots of different movies. You know, if we go back to the actual app itself, you know, I want to navigate to this movie, and then I go back to the home page and I want to go to another movie, and I want to go back to the home page and I want to go back to one of the movies that I've already selected. And we'd like to ensure that it brings that movie from the cache on the subsequent selection. But each of these movies, we can't use a static key like movie for these. We've got to parameterize the key in some way. And an obvious example and an obvious solution would be to use the movie's ID as part of the key. Because as well, let's suppose we expanded out this application so that we also had pages relating to actors. And an actor has an ID. And we'd like to be able to distinguish between entries in our cache that related to a particular actor versus entries in our cache that related to a particular movie. They both have IDs, but there's no way of distinguishing between an actor's ID and a movie's ID. we'd have to qualify it some other way. So what I'm trying to get at is the query key and the design of the query key can be, it's a design decision, right? In general, I'm saying the query key can be something simple as a string, which we saw in the case of discover, or it could be something much more complex than that. It could be an array structure, an object structure. The actual key itself now can be a complex structure. But as long as that complex structure is serializable, then it can be entered in our cache as a key value, as long as it's serializable. Going to our movies example, when we want to ask the cache, do you have a particular movie in your data store? Then maybe this might be my key construct for a movie. And I've just arbitrarily said, I'm going to store key as an array. Okay, it's going to be serialized at the end of the day, but it's an array. There's a static part of the array, the first entry. So that kind of tells me that this key, when I see it in the cache, it actually relates to a movie. And then there's the parameter, or there's the dynamic part, which will be the movie's ID. So that's actually my key in this case. And we would expect then that if we could look inside the cache itself, which we can, as I'll show you in a second, we'll see cache entries that actually look like this in serialized form. The query function is the same as before. In this case, it will just be getting a particular movie or making a different TMDB call. However, we need to somehow pass this information though to the query function, and the query function needs to extract this particular part of the key because it's going to need to make the request to TMDB, and it's only this part of the key that it needs in order to make the TMDB call. So how does our query function, how does it see this entire key, and how can it manipulate or kind of drill down into it? And that's what I'm trying to get across here. So the query function, by default, it takes a single argument. And that argument is bound to this data structure here. And all I'm doing in my code is I'm using destructuring. So args.query, well, sorry, slight misinformation there. Args is not bound to this here. Args is bound to an object, and one property within that object is the query key property. So args.query key, that expression is actually going to be referring to this data structure here. And all I'm doing down here is I'm just doing some array destructuring. That's what I'm doing here. I'm doing array destructuring. So ID part, that's going to now be a variable. And the variable is going to be referring to this little object here. And then I'm going ID part, and I'm extracting the ID property within that object. So ultimately now I'm going to have a variable called ID. And that variable in this particular example is going to be pointing at the integer 1234. And then I can make my HTTP request using 1234 as the movie ID. So the key point is when you want to have parameterized keys, if you like, you need to use something other than a static string to encode your cache key. And it can be anything really. I've just decided to use the array structure and an object structure within that array. You might argue that's a little bit overcomplicating the whole thing, and you wouldn't be far wrong, but you'll see this style used a lot if you read around the use of this library. Going back to my app, that means we need to go into the movie details page and make some changes as well. And in this case, we're going to take out this code, and we're going to replace it with this code here. Save it. Going to do a manual refresh. Select the first movie. That was a cache miss. Back to the home page. Select the same first movie, and there's no extra network communication going on. Cache hit has occurred. Back to the home page. Select a different movie, and we do get the cache miss. So it's kind of mission accomplished. If we just again look at the code that we've substituted in, kind of explained it really because it's what I included in the screenshot. Here's the use query hook again with my key, and I'm just where ID is coming from is I'm just using the use params hook, which we saw a couple of weeks ago. That extracts, because if we look at the URL that's generated in the browser, you know, it includes the movie ID. It includes the movie ID. So I'm just grabbing that off that ID from the browser's address bar, and I'm using it here. You know, if I want, supposing I want to change this, I want to make it more specific. If I go movie ID, then that just simply means I've got to now go into my query function and destructure this entire structure. So here's my query function, and I'm now I'm not looking for ID any longer. I'm looking for something called movie ID. Yeah. And clearly we're going to be using this library in this week's version of the Movies app. So you'll get a second chance to play with it. What's also nice about this third-party library is that it has its own developer tools extension, which allows us to see what's actually happening inside the cache itself. And the screenshot shows you that. But if we look at it live, this little icon here down at the bottom left, if we just click on that, that opens up the React Queries developer tools. I'll close the developer tools of the browser itself now, so we have some retail space. And I'm going to do a manual refresh. Now it's telling me there's only one entry in my cache. Here's the key of the entry. And if you click on it, it'll show you some detail on that cache entry. And down here is the actual value associated with that key. The value now is the full HTTP response. And you remember when you make the TMDB request to the discovery endpoint, you've got to drill down before you get the actual movies themselves. The movies themselves are inside here in the results object. And here are my 20 movies. If I select a particular movie, new entry has popped into my cache. That's the key. Same thing. If we click on it, we can see the actual value associated with that key. Go back to my home page, select a different movie. Okay, so you can see the actual cache building up, which is really nice feature. Obviously now you would not make this available to your end users. And what you can also do is you can kind of manipulate the cache. So these buttons here allow you to manipulate it. By manipulate it, I mean you can force a refetching of the data, even though its TTL may not have expired. For whatever reason, you might want to do that. You can explicitly remove an entry from the cache. I've documented them on the next slide. Okay. So the refresh button forces an immediate re-requesting of the data from the back end. The invalidate, we talk about the notion of data being stale in the cache. When data is stale, that means it's in need of being refetched. That, as we know now, is controlled by the TTL. But if for whatever reason you want to preempt that TTL expiring and just set the particular entry to be stale, then you can click on the invalidate button or option over here, and it sets it as being stale. What that means is that when your React code requests a particular key and the React query checks that key, it does have it in its cache, but it notices that the entry has been tagged as stale or it's invalidated. It will then re-request the data from the backend. In other words, it'll execute the query function. That's the way kind of it works. So even though the entry is there and it hasn't removed it from the cache yet, it will still refetch it and overwrite the current entry. Reset, what does reset do? Only applies when, what we're conveniently not encountering here now is when your React app can actually update or change the data that it has retrieved from your backend. So what happens there, that's kind of complicates it. In other words, the data can be mutated. Well, I guess we should update it at the backend first and then update it in the cache. But there is an issue there that you would need to be aware of. But as I said, I kind of conveniently sidestep it. The remove button removes an entry from the cache. And that's it really, in terms of this one aspect of state management, which is the use of caching, and we know why caching is a good idea. And it only applies to server state data. So you can play with the little app that I've given you, which is always better to play with the smallest app that you can when you're trying to learn a particular piece of technology. But we also bring it into the slightly bigger application that we're rolling out in the lab.